Happy Thursday. Today is April 30th. This is for Math 1, and we're going to be talking about graphing systems of linear equations. So this is going to be exactly like we did yesterday, except since it's a system, it's going to have more than one graph at the same time, okay? So we're going to go ahead and get started on our first example here. So the first thing we're going to do is exactly like we did yesterday. We're going to go ahead and graph them, okay? And there are a couple of different ways to do this, and I'll talk about them as we go through them, okay? So I'm going to do the first one first. Y is less than or equal to 1/2 x plus 2. And I'm going to just graph the line first. So it starts at a positive 2 on the y-intercept. So I'm going to go up 2, make a point. And then the slope is 1/2. So let's change in y over change in x. So up 1, right 2, up 1, right 2. Or I could go down 1, left 2, because a negative divided by a negative is still a positive. Okay, I'm going to go ahead and connect that. Notice that it has an equal to, so it's going to be a solid line. Okay. And I'm using colors so you can tell which line is which. I think it helps to differentiate. So then we're going to do the same thing for the other one. I'm not worrying about shading yet. We'll get to that in a minute. So for the other one, starts at a positive 1. So I'm going to go up 1, make a point. And then the slope is negative 2/3. So change in y over change in x. So down 2, right 3. Okay, or I could go up 2 and left 3. Remember, you only use the negative sign once. And then notice it doesn't have an equal to, so it's going to be dashed. Okay. Now, what you'll notice is that there are 4 different regions that it creates. There's one up here on the top, one over here, one down here, and one over here. The tricky part is ignoring, right now, you got to ignore the background, the axes. You're just paying attention to the 2 lines where they cross. So I need to test points in the 4 regions to see which one of them give me true, true. And it has to be true for both of them to know which of the 4 regions is my solution. Okay, so it's only going to be like a triangular shape solution, not the entire like top or bottom. Okay, so I'm going to start testing, and I'm going to use the same colors so you can see which equations I'm using, which inequalities I'm using. So I'm going to start with the top one, and I'm going to pick a point. Actually, first, let's go ahead and pick a point in each region. So over here, if you can have 0 for your x, it'll make it easier, if you can. Okay, so here, let's say I could pick the point 2, 0. I'm going to use 2, 0 from this region. From this region down here, I could use the point 0, 0. So I'm going to pick 0, 0 for this region. Over here, let's say, let's say that I use the point here. It doesn't really matter. I'll just pick a point out here because there's nothing on the y-axis. So I'll pick this point right here, which is 1, 2, 3, 1, 2. So it's -3, 2. And then we'll pick a point over here. Just go with this one. 1, 2, 3. So that's 0, 3. Okay. Now, on this one, if I wanted to make my x 0, like I talked about, it would have to be like a fraction number. So that's up to you if you want to pick a number in there. Otherwise, it doesn't really matter. Okay, so we have 4 points, and we're going to test them in. Okay, so I'm going to start with region 1, and I'm going to test them into region 1. Okay, so I'm just going to number it so you can see. So region 1 is the point 0, 3. I'm going to start with the top one, and I'm going to substitute in 0, 3. So y is 3. Less than or equal to 1/2, x is 0, plus 2. Okay, so 0 times 1/2 is 0. That's why I like that if I can make that a 0. Is 3 less than or equal to 2? No, it is not. Now, I could test it in the other one, but if I already got 1 is not working, there's no point. That region is not going to be a solution. Okay, so I would just stop there and say that region is not a solution. Let's try region number 2. Okay, so region number 2, I'm going to again start with the same one. I'm using 2, 0. So y is 0, less than or equal to 1/2. X is 2. Okay, half of 2 is 1. And by the way, if the fractions confuse you, remember you can put 2 over 1, or you can also write half as 0.5. That's fine too. 1 plus 2 is 3. Is 0 less than or equal to 3? Yes, it is. So now I need to see if that works with the other inequality as well. I'm going to test it into this one as well. 0, 2. So 0 is greater than negative 2/3 times 2 plus 1. Okay, so 0 is greater than, and here I'm going to put it as over 1, and I multiply top to top, bottom to bottom. So negative 2 times 2 is negative 4. 3 times 1 on the bottom is 3. Okay, and then negative 4 over 3, I'm just going to write that, and you could use a decimal as well, it doesn't matter, but negative 4 over 3 is negative 1 1/3, or negative 1.33333 forever, plus 1. So negative 1 plus 1 is 0. So then I end up with just 0 is greater than, I still have that negative 1/3 left over. Because I already used the negative 1 part and there's still the negative 1/3. So is 0 greater than negative 1/3? It is greater than negative 1/3. So then that means that this is where my solution is in region 2. Now, once I find my solution, I'm not going to waste my time substituting in the other ones because that's just extra work. So my solution is going to be in this triangular region right here. Now, it's important when you shade it that you go all the way into the triangle. Don't let the axes stop you. So don't think about these lines. These lines, the pencil ones, don't matter, the axes. Focusing on the lines that we tested. So everything in here is a solution. So there you go. There's my final solution. Okay. All right. Okay, let's try another one, and I'll do it a little differently on the second one so that you can decide kind of which method you prefer to use. It's up to you. So on the second example, this is like how they did it in the examples in the written notes, okay? So we're going to do the same thing. We're going to start graphing first. So y is greater than or equal to 2x minus 1, so start without your negative 1. Remember, it's 2 over 1, so I'm going to go up 2, right 1, up 2, right 1, up 2, right 1. Or I could do negative divided by negative, it's still positive 2. So down 2, left 1, down 2, left 1. Okay, notice it has an equal to, so I'm going to make it a solid line. Okay. Same thing for the other one. Y is less than negative x. Remember that there's an imaginary plus 0 here, right? So I'm going to start at 0. And then my slope, remember there's a 1 over 1 in front. So I'm going to go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Okay, or I could put the negative on the bottom instead and make the top positive. So up 1, left 1, up 1, left 1, and so on. Whatever you do, don't make them both negative because a negative divided by negative would be a positive x. Okay, so don't go down into the left. All right, notice this does not have an equal to, so I'm going to make it dashed. Okay. All right. So what I could also do is find the shadings separately. Okay. So this is what they did in the example. So for the purple one, I can look and find out which side I'm supposed to shade for the purple one. So I can pick a number from this side and a number from this side. Again, any number that's not on the line, that will help me. Can't use 0, 0 this time because 0, 0 is on my line. So let's say I use, I don't know, I'm doing this for the purplish line. Let's just use this point right here, which is negative 2, comma 0. Yeah. Okay, so then I'm going to substitute that in. We're talking about the purple one. So I'm going to plug that into the purple one. So y is 0, less than negative, and then x is -2. Be careful that you still have that negative on the outside that was originally there, and then the 2 is negative. Okay, so 0 is less than, -2 is +2. So 0 less than 2? Yes, it is. So I would want to shade on the side of the line where that is. So that means I'd shade this way, right, below the line. And I can do the same thing for the blue one. Find which side I want to shade on. This one I can actually use 0, 0, but I don't want to do it just because it's going to get a little confusing there. So I'm just going to pick another point. Let's use this one. Let's use 0, 1. So I'm going to test that one in the blue one. So 1 is greater than or equal to 2 times 0 minus 1. 1 is greater than or equal to 2 times 0 is just 0. So is 1 greater than or equal to 1? Yes, it is greater than or equal to 1. So that means I want to shade on the line, side of the line where this point is. So I would shade this way and this way. And then what I can do is I can look for the place where they'd both be shaded. So right here, you can see that I'd shade on this side, but this one is shading down. So this is not it. Over here, neither one of the arrows are pointing in, so it's not this one. This one, only one arrow is pointing into it. But see how this region right here, see how it's the arrow's pointing in here and the arrow's pointing in here? That means this is the region that I want to use. This is my solution region. So I'm going to shade in my solution region. Okay, and there's my solution. Now I do want to say one thing. Obviously this method is shorter because I only had to substitute twice versus this one up here. I technically could have had to substitute 8 times, twice for each region. Okay, but this one you have to be careful of, like noticing where both arrows are pointing in. So if you can see that, then sure, that makes it easier on you. Feel free to do that. Okay, that's up to you. I'll take both ways. Just be careful if you're going to use this method that's a little shorter. Be careful that you're looking where both arrows are pointing in so you can graph the right shaded region. Okay, if you guys have any questions, feel free to contact me on Remind, Google Classroom, or email as always, and have a wonderful day.